Now next question that we are going to study is from April 2014 exam, question 4. So give the heading April 2014 exam, question 4. Now I am going to read the question for you guys. We have a load of mass 3 ton. How much load of mass 3 ton? 3 ton means 3000 kg is resting on a tapered block. Tapered block is what? A is to be raised using two identical wedges. So we have to raise a wedge on which there is a load of 3 ton. Okay. And it is that tapered block is raised using two wedges B and C as shown in figure question 4. Why figure question 4? In that exam it was a question 4. So that's why figure question 4. Now they have given two coefficient of friction. The coefficient of friction between the wedges and block A is 0.3 and between the wedges and ground is 0.4. The load on each wedge is assumed to be remain equal, means each wedge will have a same load, means B and C will have a same load. See the scenario here. And what they are asking us here in this question, calculate the horizontal force P required at each wedge. Our target is what? We have to find out force P required at each wedge. Okay. Now try to see the scenario here. What is the scenario I want to say? So first of all, what we have? This is what a tapered block. See the point here, everyone. Huh? Don't write anything, don't draw anything. Just observe the things carefully here. Okay. So this is what our tapered block. Okay. See, yeah, this is tapered block. Okay. This is what a tapered block A. There is a wedge. See the point here. This is a wedge C on this side. Okay. This is a what, guys? Wedge C. And this is a what? This is a wedge C. And this is a what? Wedge B. Okay. Now how much will be the weight? Total weight will be how much? Total weight will be how much? On this A, on this tapered block. How much will be the total weight? Weight, how it is weight? Weight is vertically downward. So total load on is what? 3000. Okay. 3 ton. So 3000 G. Okay. Now see the scenario here. Here on both sides, on this side, force P. Here force is denoted by P. Sometimes don't worry. Sometimes force is denoted by P. So don't get confused. And in this question, what is our target? In this question, what is our target? We have to find out what? P. What we have to find out? We have to find out a P. Okay, that is what our target. Now the next thing. Okay, so our target in this question is what? We have to find out P. P is applying on both sides. On this wedge B and C. On both wedges, we have a equal load. Load is distributed on both load, means 50% its load is taken by the wedge B and 50% of this load is taken by the wedge C. Okay, see the scenario here. So you got the target. Now they have given us a two coefficient of friction. Coefficient of friction between the wedges and block A, that tapered block A. So how much coefficient of friction for this surface? We will say this is what? A mu1. So mu1 is equal to what they have given? 0.3. And then okay, and between the wedges and ground, means this is wedge and ground. For this purpose, how much they have given us? Coefficient of friction? Mu2, we will say mu2. How much they have given? 0.4. Okay. Try to see the scenario. So this is what a given condition to us. Okay. Now the next scenario will be what? Try to see the next scenario here in this question. Try to see the next scenario. Now, so phi1, coefficient of friction for this one. Phi1 will be equal to what, guys? Phi1 will be equal to what? Tan inverse of mu1. So tan inverse of how much, guys? Tan inverse of mu1. Mu1 means how much? 0.3. So tan inverse of 0.3 will be how much, guys? Please everyone do the calculation and let me know tan inverse of 0.3. How much? 16.7 degree. Okay, good. Then phi 2 will be equal to what? Tan inverse of mu 2. Tan inverse of mu 2 is what? Tan inverse of what? 0.4. How much? 21.8 degree. Okay, very good. Okay guys, so any doubt till now? So in this question, what are the things they have given us? They have given us tapered block. On that tapered block there is a load of 3 ton, means, so what will be the total weight? Total weight will be 3000 g. Then we have to lift this load. Okay, we have to lift this tapered block. For lifting we are using 2 wedges. On these 2 wedges load is equally distributed and we are applying a force P. And our target in this question is what? This is what our target. What we have to find out in this question? We have to find out force P. Okay guys, are you getting my point? Try to see the scenario here. Okay. So now guys, first of all, try to draw this drawing properly. And one thing is missing here. Which thing I have not shown here from the given things? On this drawing, which things I have not shown? Angle. What things, which things I have not shown? Angle. So how much angle they have given us? Okay. This angle will be what guys? 5 degree. So it must be same on both sides. This will be also 5 degree. Okay. So please everyone, write down all these things. Phi 1, phi 2, it is not a, we can show, where it will come, I will show phi 1, phi 2. See, this phi 1, phi 2 is not on this drawing. This phi 1, phi 2 is not on this drawing. Why? What is the meaning of phi? Phi means what? Angle of friction. And it is an angle between R and Rn. What is meant by phi? Phi means what? Angle between R and Rn. Is it here I have shown R and Rn? No. So that's why phi 1, phi 2 I have not shown here on this drawing. Okay, are you getting my point? Okay, so please, I will show phi 1, phi 2 on the next drawing. Okay. Now try to see the scenario here. What is our target here? What we have to find out? We have to find out P. Okay, see, I am going to explain you one important thing. Suppose I am applying some force on this board. Suppose I am going to push this board. Try to see the scenario. What will happen? When I am going to push this board, okay, suppose I am going to do push-ups on this board. What will happen guys? Suppose I am going to do push-ups on this board. What will happen? When I apply some force, okay, board will push me back. Okay, correct. Means for every action there will be what? Opposite reaction. For every action there will be what guys? Opposite reaction. Okay, try to see the scenario here. Means see, suppose there is a one object. Suppose this is a ground. Okay. This object is applying force on this ground. This object is what guys? I am separating this. Imaginarily I am separating these two scenario. What I am doing? Imaginarily separating. This is what? A ground. And this is an object. Okay. This object is doing what? This object is doing what? Applying force on this ground. This object is doing what? Applying some force on this ground. So what will happen? Automatically ground will apply opposite force on this one. What will happen guys? Ground will apply opposite force on this one. Means for every action there is equal and opposite reaction. Newton's third law of motion. Okay, are you getting my point? Try to see the scenario. Very, very important discussion. Okay, now why I am telling you all these things? Okay, means what is the importance of this one? For every action there is equal and opposite reaction. Newton's third law of motion. Okay, the same scenario we are going to apply in this numerical. Okay, see the scenario here. What is the scenario here? I am going to draw, this is a block A, tapered block A. Try to see the scenario guys. Try to see the drawing. Here drawing is very, very important. Not only here, throughout the mechanics. The only important thing in mechanics is what? Okay. Not I will say only, most important thing. Okay. Drawing. Okay. So on this one, I am going to separate this. I am separating these three masses imaginarily. Means actually they are attached to each other. Means A is rest on B and C. Actually they are rest on each other. But just for making things simple, for doing the calculation, for solving this numerical, what I am going to do? I am disassembling them. Okay. Okay. See the scenario. Okay. So I am going to disassemble them. Okay. So this is what our A. This is what our tapered block A. Then try to see the scenario next is what, guys, here. This will be what? This will be what? This will be what? Our C. Okay, good, very good, C. Then next point will be what? This will be what, guys? Okay, this will be what? B. Okay, see the scenario here, everyone. Okay, now on A, which force will be here? On A, which force will be here? 3000 G. Okay, on B, from this side, a force P is applied. Don't consider it is a pressure, it is a force P. That is what we have to find out. Don't consider it is a P. Sometimes in mechanics we denote force by P. Okay, so don't worry. So then this is what? P. Okay, these are the external forces acting. Okay, now what will happen, guys? Now what will happen? The next scenario will be what? Now see, this object C tried to go down. This object C, this wedge C tried to go what, guys? Try to go down. But what will ground do? What will this ground will do? Ground will apply opposite force. What this will ground will do? Apply opposite force, and this reaction we call it as a normal reaction Rn2. Try to see the scenario here. Now due to this force P, this wedge C tried to go in. Due to force P, what will happen, guys? Due to force P, what will happen? This wedge C tried to go in, see, tried to go in. Then what will happen? Friction force will be what, guys? Opposite to the motion. So here there will be what, guys? Normal reaction. This normal reaction will be what? We will say Rn2. Why I am saying Rn2? Because we assumed it as a mu2. So for this bottom floor, Rn2. Okay. Now what will happen? Motion will be on this side. Then what will happen? Friction force will be what, guys? Opposite to the motion. And this will be what? Friction force Fr2. Okay. Any doubt in this discussion, guys? Try to see the scenario here. Now here loading is what, guys? Loading is what? Symmetrical. So whatever the forces on C, the same symmetrical mirror image is on the what, guys? Mirror image will be on the B. Means if here reaction is Rn2, then same reaction will be developed here. See the scenario here. The same reaction will be developed here, and this will be also we can consider as a Rn2, because loading is what here? Symmetrical. Okay. So Rn2. Then B is tried to go here. So what will happen? B is tried to go here. B is going this side due to force P. What will happen? Friction force will be what? Opposite to the motion. Friction force will be what, guys? See the friction force. This friction force is visible to everyone. So friction force will be on this side. So this will be what? Fr2. Okay, good. Till now any doubt, guys? Try to see the scenario here. Till now any doubt? Okay. Now the next point. Okay. Guys, I told you. Normal reaction is always normal to the plane. Normal reaction is what, guys? Normal reaction is what? Normal to the plane. Okay. See the scenario. When this A is going on, when A is resting on C, when this block A is resting on wedge C, what will happen? This A will apply some force on C. What will happen, guys? This A will apply some force on C, and that force will be what? Guys, normal to the plane. So when A rests on C, what will happen? When A rests on C, if I am resting on a ground, it means what, guys? I am applying some force on the ground, and that force is what, guys? See the scenario. If I am resting on the ground, suppose I am resting currently, I am resting in the classroom, what will happen? I am applying some force on the ground. Okay, see the point here. So what will be the scenario? If I am resting on the ground, I am applying some force on the ground. So whatever the force I apply on the ground, opposite force applied by the ground on me. So here what will happen? A is resting on a C. So what will A will do? A will apply some force on a C, and that force will be what? Perpendicular to the plane. And that perpendicular to the plane force is what, guys? See the scenario here. Huh? Very, very important discussion. See the scenario. So here, what we are going to do? So there will be what, guys? There will be what? A will apply some force on a C. So this will be what, guys? This will be what? This will be what, guys? Normal reaction. And this is, okay? This will be what? No, this will not be mg. This will be normal reaction. Weight is acting on A. Due to that, there will be some force. Okay, are you getting my point? So this weight will directly not will come on C. Reaction will come. Okay, guys, are you getting my point? Try to see the scenario here. So there will be what, guys? So there will be what? See the logic. So there will be what? A force will be applied on C. And this force we will say it as a Rn1. Any doubt in this Rn1? Any doubt in this Rn1, guys? See the scenario. Now Rn1 is what? What is the speciality of Rn1? Rn1 is what? Force on C. What is the meaning of Rn1, guys? For our understanding, I am writing. In exam, no need of this one. What is meaning of Rn1? What is meaning of Rn1? Force on C. Okay. Normal force. Normal means what? What is the meaning of word normal, guys? Normal means what? Perpendicular to the plane. So normal force on C due to what, guys? Due to A. Any doubt in this one? Rn1? Guys, any doubt in Rn1? Try to see the scenario. Huh? Very, very important discussion. Okay, so we got it Rn1. Then, so here 3000 G will not come directly. 3000 G. So what is happening here? See force here like this. Huh? See the point here. Now the next scenario will be what, guys? Next scenario will be what? See the next scenario. Next scenario will be what? What will be the next scenario? Now this C is try to go this side. If C is try to go this side, so on this side there is a friction. On these two planes there will be what, guys? Friction. So friction force will be what? Opposite to the motion. Friction force will be what, guys? See the friction force. So this friction force we will say it as a Fr1. Any doubt till Fr1? Guys, any doubt in till Fr1? Okay, good. Now try to see the scenario. What I told you, for every action there is a equal and opposite reaction. What we discussed, guys? For every action there is what? Equal and opposite reaction. And what is the meaning of equal and opposite reaction? Try to see the, means if Rn1 is the force on C due to A, so what will happen? Opposite force C will apply on A. What will happen, guys? Opposite force what will do? C will apply on A. So that will be what? That will be what, guys? That will be what? So this will be what? This force C. Action. Then there will be what? Okay, see the scenario. So this force will be also what? Rn1. Okay, guys, are you getting my point? For every action there is equal and opposite reaction. Now, if C is going to like this, what will happen? A will going to like this. Okay, A will try to go like this. If A will try to go like this, there will be friction force. And this friction force means if A will try to go like this, C try to go like this, then A will do what? A will try to go like this. See the scenario here, everyone. Huh? Okay, guys, are you getting my point? So what will happen if the motion of A means this plane motion will be this side, then friction force will be what? This friction force will be what, guys? Opposite to motion, and this will be what? Fr1. Okay, anyone have any doubt in this discussion? Okay, good. So no, same force na, same na, action reaction, because they are both are in contact each other na. See this plane and this plane, so this will not be Rn3. Same Rn1, Fr1, not Rn3. Okay, why this is not a Rn3? Okay, are you getting my point? Try to see the scenario here. Oh, okay, good, very good. Okay guys, till now any doubt? Okay, you got this drawing, everyone? Now guys, we discussed already. What we discussed already guys, what we discussed? Here loading is what? Symmetrical. So whatever the things on this side, the same thing will be on, mirror image will be on this side. So here, there will be what guys? A reaction force. There will be what? A reaction force, that will be what? Normal to the plane. Okay, there will be what? Reaction force, that will be what? Normal to the plane. And that is what? Rn1. This will be what guys? Rn1. See the scenario here. Very, very important discussion. Please let me know if you have any doubt. Now see, try to go this side. Friction force will be what? Opposite. So this will be what? Fr1. Okay, good. Now for every action there is equal and opposite reaction. So here will also what will happen? So what will happen guys? Here also. See the scenario here, drawing. So here I am drawing a perpendicular. So whenever I say Rn means what? Normal. Normal means what? Perpendicular. So see the scenario here. Okay. So this will be what guys? Rn. What will be the scenario? Rn1. Okay. Now if this is try to go like this, if this is try to go like this, then what about A? A will try to go like this. If B is try to go like this plane is try to go like this, what will happen? A will try to go like this and friction force will be what guys? Opposite. Okay, see the scenario here. Friction force will be what? Opposite. And this will be what? Fr1. This will be what guys? Fr1. Same, Fr1. See mirror image of each other, because loading is what? Symmetrical. Okay. Any doubt till now? See the drawing here everyone. And what is the speciality of this Rn1? See, this Rn1 is what? Normal force on C due to A. And what is the speciality of this one? Normal force on A due to what guys? Due to C. Okay guys, are you getting my point? Means action, reaction. Okay, opposite to each other. Okay, try to see the scenario here. Now, what we are going to do? See, initially, so here we got how many systems? So here we got how many systems? Here we got how many systems? This is a one system. This is a one force system. And this will be what? Our third force system. So here, how many total force system with us? Here, how many total force system with us? 3. This is another one, this is another one, this is another one. And here, see the point here, very, very important discussion we are doing. So here we have a 3 force system, means 3 systems are there. Okay, 3 force systems are there. Okay. So see the scenario here. So now what we are going to do? Our target is what? We have to find out P. What is our target? Our target is what? We have to find out force P required to move, okay, to lift the load. That is what our target, okay. So for that purpose, so we will start with our discussion 3000 G. Okay, so this with A. For A, how many forces are there? For A, how many forces are there with us? For A, how many forces with us here? 5 forces. 5 forces are, but what we are going to do? We are going to replace these 2 forces by what guys? See the scenario. We are going to replace these 2 forces by what? Their resultant force R, and their resultant force will be what guys? R. R stand for what? What is the meaning of R? Resultant reaction, and we will say it as R1. And see, what will be then this angle? This is what? Here angle of friction is what for this plane? Phi1. So this angle will be what? Phi1. In this drawing we can show Phi1, because here it is not possible, because here we are not showing normal reaction and resultant reaction. So where we can, is it possible to show? On this drawing. Okay guys, are you getting my point? Now here vertical line, try to see the scenario here. I am going to draw one dotted vertical line. Okay. What will be this angle, guys? This will be vertical line, huh? See the scenario here. What will be this angle? What will be this angle, guys? See, 5 degrees. See the angle of plane. Angle of plane, this is what, guys? This inclined plane angle is how much? 5 degree. So this angle by default is what? 5 degree. Okay, see the scenario here. Huh? For your understanding, I am writing its explanation. How we are getting it is 5 degree. See, guys, this is what our normal reaction. Rn. See the point, huh? Rn1. See the point here. I am explaining you how we are getting that one. So Rn1, this is what? Perpendicular to the plane. Okay, sorry, vertical line. This is a vertical line. Okay. Now see the point here. Okay. So this angle is how much they have given us? 5 degree. In the question, this angle is how much, guys? 5 degree. See the point here. 5 degree this angle. So this angle is what? 5 degree. So then what about this angle? This angle will be what? 85 degree. Not to the scale drawing. Huh? Otherwise you will say, sir, how this is 5 degree? Okay, so not to the scale. 5 degree. This angle will be 85 degree. And there these two summations will be what? Again 90 degree. Okay. So you got my point, guys. We have seen such type of scenario in earlier numerical. So you got it how we are getting 5 degree. So if this is 5 degree, then this side will be also what, guys? Same. 5 degree. Then here also we can make a same type of rectangle. See the point here. Here also we can make the same type of rectangle here. So what will be the scenario here? This will be what? This will be what? Our resultant reaction same. R1. And what is the angle between R1 and Rn1? Same, phi1. Okay. Because here loading is symmetrical. See, mirror image of each other. Okay. Then we will come to this side. So net resultant on this side R1. Same opposite must be on this side. So here again, here also we are going to form what, guys? Here also what we are going to do? We are going to form a rectangle. See the scenario, huh? What we are going to do? We are going to form a rectangle. Then see the point here. We have formed a rectangle here. And then this will be what our resultant reaction. What will be this resultant reaction? Again R1. Okay. And what is this R1 and angle between Rn1? This angle will be what? Phi1. See the scenario, same scenario here. Because coefficient of friction is same here. Whatever the same here. And here I am drawing one vertical line. A dotted. What will be this angle, guys? What will be this angle? This black one, this one? 5 degree. Okay, good. So same scenario we can draw here. See the scenario, complexity of the drawing. After completing this lecture means, after completing this today's lecture, okay, what you have to do, try to draw this drawing 2 to 3 times, then and only then you will become expert in such type of drawing. Okay, so don't worry. Then here there will be what? Again, resultant reaction. This will be what, guys? What will be this resultant reaction? Same. R1, this force, this angle will be what? Phi1. And here there will be what? Normal. This angle will be what, guys? 5 degree. Okay, good. So any doubt in this discussion? So here on A, initially 5 forces. 3000 G, Fr1, Rn1, Fr1, Rn2, Rn1. But what we have done? We have replaced Fr1, Rn1 by R1, Fr1, Rn1 by R1. Okay. Same here also. With B also what we are going to do? We are going to replace this one, this side. Okay, bottom side. Again we are going to replace these 2 forces by what, guys? Here there will be what? We will denote it is by R2. And this R2's angle with respect to Rn2, this angle is what? Phi2. Because here we assumed coefficient of friction mu2 and corresponding to mu2. Okay, let's try to see the scenario. Corresponding to mu2, there is angle is what? Phi2. So angle of friction is here Phi2. So that's why here I have shown Phi2. Okay, guys, are you getting my point? Try to see the scenario here. Okay, then next point is what here? Then next point will be here what, guys? See the scenario here. Okay, so this will be what? This will be what? Our resultant reaction R2. Okay. I will use for standard practice same color pen. Okay. See the point here, everyone. Okay. Guys, see the scenario here. So this will be what? So this will be our what? Our resultant reaction what? The resultant reaction is what? R2, and this angle of R2 is what, guys? This is what? Phi 2. And why it is phi 2? Because here we assumed coefficient of friction mu2 and corresponding mu2 angle of friction is what? Phi 2. Okay. So that's why here R2 and Rn2 angle is what? Phi 2. Okay. Guys, any doubt in this discussion? Okay. Try to see the scenario. Very simple things. See, initially you may feel, sir, what are you doing? There are a lot of complications here. That is the initial stage. But don't worry. Try to do these things 2 to 3 times today in today's lecture, after completing today's lecture. And then I will tell you, definitely you will become expert in such type of things. See, speciality of mechanics is what? Here you don't have to memorize anything. Very less things to memorize. Very, very less. Here all things are concept. And if you have to solve problems 2 to 3 times now, then you will become expert in all such type of things. Automatically your logic will get developed. Okay. So the only important things is what? You have to do practice. Try to draw the drawing problem again and again. Try to solve the things without watching solutions, okay, without looking at solution. Then automatically you will get, means if you new questions will come in the exam now, then automatically you will get an idea what you have to do. Okay, so please everyone try to do this drawing properly. And you got this, how we are getting this angle? We got this 5 degree, okay, okay, good. Please everyone, and okay, please everyone complete this drawing. Now try to see the scenario here, what we have to do. Now what is our target? Our target is what? We have to find out this P. What we have to find out? We have to find out P. Now for getting P, what we are going to do? Try to see the scenario, what we are going to do. To get the P, what we are going to do? See the scenario. We will start our discussion with tapered block A. What we are going to do? We are going to start our discussion with what? This tapered block A. Okay, see the point here. So what is this tapered block A? Here on this tapered block A, how many forces initially are there? Initially how many forces? 5 forces. Which are 5 forces? This first one 3000 G. Then these two FR1, RN1. So 3 forces. These 2 forces FR1, RN1. So here in this way there are total 5 forces initially. But what we have done? We replace these 2 by what? R11. We replace these 2 by what? R1. So at the end finally how many forces are remaining? 3 forces are remaining. At the end how many forces are remaining? 3 forces are remaining. So here this tapered block will become what? 3-force system. And whenever we have a 3-force system, what will we will do? If coplanar concurrent 3-force system is in equilibrium, what will do? They will form a what, guys? Closed triangle. Okay, they will form a what? Closed triangle. Okay. Okay, see the scenario here. Very, very important discussion. Okay, so we will start our discussion with what? For tapered block A. Okay, see the scenario. For tapered block A. Okay, tapered block A. We are seeing the discussion for tapered block A. So for tapered block A, if you observe the scenario for tapered block A, okay, so we will start as usual. So always in any drawing, try to see is there any horizontal line or vertical line. But here vertical line is there, that is what? A 3000 G, our weight. So we will use 3000 G as our reference. So what we will do? We will use this 3000 G as what? Our reference. So this is what? Our 3000 G. Okay. G means what? Acceleration due to gravity. So don't get confused. So here, okay. Then where 3000 G ended, here R1. This R1 is making angle how much with respect to vertical? This R1 is making how much angle with respect to vertical? 5 degree plus phi 1. How much it is making angle with respect to our vertical? 5 degree plus phi 1. So 5 degree plus phi 1 will be what, guys? 5 degree plus phi 1 will be what? So we are going to draw this R1. I am drawing this R1. See this like this. Okay. So here I am drawing to draw R1 like this. See the point here. So this will be what? Our R1. Okay. See the point here, everyone. So this will be what? Our R1. Okay. This R1. And this R1 is making how much angle with respect to vertical? Phi 1 plus phi. Okay. So this angle will be what, guys? Phi 1 plus 5 degree. Okay, good. Then there will be what, guys? This will be what? Okay. So this R1 is like this. So another R1 is what? There are two R1 here. So this R1 will be like this. So for this R1, what we are going to do? We are going to make like this. This R1 is also making how much angle? See the scenario. This R1 will be what will do? This R1 will be what it will do? Guys, this R1 is also how much angle it is making? Same, phi 1 plus 5 degree. So this is phi 1 plus 5 degree. Okay, see the scenario here. Then we will assume this angle as a what? Theta 1. Till now any doubt in guys in this discussion? Till now any doubt in this diagram? Force vector diagram for. So this is what will be the name of this figure? What we will say? Force vector diagram. Okay, what we will say on this drawing? We will say it as a force vector diagram. Okay guys, try to see the scenario here. Then see, sum of these three angles will be what, guys? 180 degree. Sum of these three angles will be what? 180 degree. So theta 1 plus phi 1 plus 5 degree, this one. Then phi 1 plus 5 degree equal to what? 180 degree. Okay. So theta 1 plus 2 phi 1. See the scenario here, everyone. So 5 plus 5, 10. And that will be equal to what? 180 degree. So theta 1 will be equal to what? 180 minus 2 times. What is the value of phi 1, guys? What is the value of phi 1 we calculated? What is the value of phi 1 we calculated? 16.7. Check it out. So 16.7 minus 10. Okay, see the point. 180 minus 2 times 16.7. Okay. So everyone please do the calculation and tell me the value of theta 1. Everyone please do this calculation. 180 minus 2, 16.7 minus 10. How much will be the answer? 136.6 degree. Okay, so we got it, theta 1. Now see, from this drawing, what we are going to find out? From this drawing, see, here we will get R1. From this drawing, what we will get? We will get, guys, what? R1. So we are going to use what? By sine rule. By sine rule. Okay. So by sine rule, opposite. See, R1's opposite is what? Phi 1 plus 5. Okay. So R1 divided by what, guys? Sine of phi 1 plus 5. See the scenario. Okay. Is equal to what, guys? Is equal to what? 3000. Opposite is what? 3000 G's opposite is what? Theta 1. And we just calculated 136.6. So 3000. What is the value of G? 9.81. Okay. So sine of theta 1. So R1 will be equal to what, guys? R1 will be equal to what? 3000 multiplied by 9.81 multiplied by sine of phi 1 is how much, guys? How much phi 1? 16.7. Check it out, guys, everyone. Divided by sine of theta 1 is how much? 136.6. Okay. So we just now calculated here theta 1 136.6. So from this expression we will get value of R1. So please everyone do this calculation and tell me the value of R1. 1537.524 Newton. Okay, so we got it, guys. What we got? R1. Okay, so from R1, so here we got R1, and from R1 we are going to find out P. Okay, so please, guys, everyone, okay, write down all these things properly, one by one, carefully. Now try to see the scenario here. What is our final target? Final target is what? We have to find out P. What is our final target? We have to find out P. And for P, what we are going to do? We are going to form a, see, from this drawing, we have drawn force vector diagram, and from force vector diagram we got R1. So whatever the value of this R1, same will be this R1. Guys, see the scenario. Whatever this R1, same action and reaction. Okay. So what we are going to do now? We are going to see wage C now. What we are going to do? We are going to see wage C. Okay, see the scenario here, everyone. So we are going to draw the drawing forward, guys, wage C. So for wage C, we are going to form what? Force vector diagram. Okay. So how we are going to draw the force vector diagram for the wage C? Okay, there are two ways to draw the force vector diagram. See, first way, both drawings will be same. Okay, so don't get confused. Okay, so there will be what, guys? This will be what? Our force P. Okay, where force P ended, what we can do? Where force P ended, so this will be what? Our R2. So we can draw R2 where force P ended. Here we can draw here, this will be what, guys? Our R2, and where R2 ended, then this will be what? See the scenario here. This will be what? Our R1. Okay, so this will be what? Our R1. Okay, any doubt in this discussion? This is a one way of drawing force vector diagram. This is a one way. Okay, this is a one way. Another one way will be, see, same P. Instead of drawing P at the top, bottom, we can draw top. So P, then see where P ended. So here we can draw, this will be what? Our R1. Okay, and then this will be what? Our R2. Okay, see the scenario here, everyone. Okay, see, same drawing. Okay, consider it is like a mirror image of each other. Okay, so anyone have any doubt in this discussion? Try to see the scenario. Here both the drawings are same. Okay, see, R1 is like this, here is R1 also like this. P is like this, here also P is like this. Okay, see the scenario here. So angles, this will be what? Our, you got now, guys, both the drawings. Okay, see the point here. This is what? Our R1. Okay, now what is the angle of R2 with respect to vertical? What is the angle of R2 with respect to vertical here? Angle of R2 with respect to vertical is what? Phi 2. So this angle will be what, guys? Phi 2. Angle of R1 with respect to vertical will be what? Angle of R1 with respect to vertical is what? Phi 1 plus phi 2. How much, guys? So this angle will be what? This angle will be what? This angle will be what? Phi 1 plus 5 degree. Okay, good. Then what we are going to do? We are going to assume this angle as what? Theta 1. This angle as what? Theta 2. And this angle as what? Theta 3. Okay. Same things we can show on this drawing. Okay. See the point here. What is the angle of R1 with respect to vertical? Angle of R1 with respect to vertical will be what? This angle will be what, guys? Angle of R1 with respect to vertical, phi 1 plus phi 2. So phi 1 plus 5 degree. What is the angle of R2 with respect to vertical? This angle will be what? phi 2. So this is what our R2. See the point here, everyone. Then we assumed here this is what a theta 1. So in this drawing, theta 1 will be what? This will be what? Theta 1. So no, theta 1, we have already taken theta 1. So we will assume theta 2, theta 3, theta 4. Okay guys, are you getting my point? This will be theta 2. We already considered theta 1 in our previous drawing. So here theta 2, theta 3, theta 4. Then if this is what a theta 2 in this drawing, this will be theta 2. This will be what? Theta 3. And this will be what? Theta 4. Okay, see the point here, everyone. Okay guys, are you getting my point? Is these drawings are okay for everyone? Is both the drawings are okay for you? You can draw force vector diagram like this, or you can draw force vector diagram like this. Both are the similar drawings. Any doubt in this discussion? Observe this drawing carefully. Okay, good. So now try to see the scenario, next scenario here. What is our target? What we have to find out? Guys, what is our target? We have to find out P. What we have to find out P. Okay, for P we need a theta 4, and for theta 4 we need a theta 2 and theta 3. See here, phi 2 and theta 2, their summation will be what? Phi 2 and theta 2, their summation will be what? 90 degree. So theta 2 will be equal to then what? 90 minus phi 2. So theta 2 will be equal to what guys? 90 minus phi 2. So 90 minus phi 2, what is the value of phi 2 guys? What is the value of phi 2? 21.8. Check it guys. Okay, so please do the calculation. 21.8. So please do the calculation. 90 minus 21.8 will be what? 91. What will be this value guys? 68.2 degree. Okay, good. Then theta 3 will be equal to what? 90 minus phi 1 plus phi 2. See the point here, everyone. So 90 minus phi 1 is how much? 16.7 plus 5. Okay. So what will be theta 3? Then what will be the value of theta 3 guys? 90 minus so 68.3 degree. Okay, good. Then these three angles summation is what? Theta 2, theta 3, theta 4. Their summation is what? 180 degree. Okay, theta 2, theta 3, theta 4. Their summation will be what? 180 degree. So theta 2 plus theta 3 plus theta 4. Their summation will be what guys? 180 degree. Try to see the scenario here. This 180 degree. So what we can say? Theta 4 will be equal to what? 180 minus theta 2 minus theta 3. So theta 4 will be equal to 180. Theta 2 will be how much guys? 68.2 minus 68.3. Check it once again, everyone. Please be sure with my calculation. Sometimes I may do mistakes in my calculation. So please be attentive. So 180, everyone please do the calculation with me. 180 minus 68.2 minus 68.3. So what will be the value we are getting guys? How much value we are getting? 43 point how much? 5 degree. So we got theta 4. Why we calculated theta 4? Because we need a P. Opposite P is what? Theta 4. So then we will apply sine rule, our favorite thing. Simple to apply. So what is sine rule saying? P opposite theta 4. So P by sine of theta 4, everyone, is equal to what guys? What we know here? We know R1. What is opposite to R1? Theta 2. So R1 divided by what guys? Sine of theta 2. Everyone try to see the scenario. Okay, good. So we need a what? P. What is the value of R1 we calculated guys? R1 is what? 15. Here I have written for my reference. Okay. So 15837. Point, check it out everyone. 153524 sine of theta 4. Theta 4 is how much? 43.5. Okay, divided by what? Sine of theta 2. Theta 2 is how much guys? Theta 2 is how much? 68.2. So everyone please do the calculation and tell me the value of P. Everyone please do the calculation. 15837 15837.3524 multiplied by sine of 43.5 divided by sine of 68.2. How much? 11741.38, or we can take directly 4 Newton. Okay, so P is force, so this is the value of force that they are asking us. This is our final answer. Okay guys, are you getting my point? Try to see the scenario here. Okay, please everyone write down all these things properly. Everyone please write down all these things properly. So now guys, now try to see the scenario here. We have seen this a long method. It is a preferred one, but sometimes there may be a chances you may do a calculation mistake. See, we have seen a long method. We have spent 1 hour, okay, at least, okay, 1 hour here, okay, on solving this question. But this is a very long, okay, very huge. Okay, now what we have to do when we are dealing with such type of numericals? What we have to do to get the answer in shortcut way? How to get the answer in shortcut way? In yesterday's lecture, we discussed few things. A horizontal force, different cases of horizontal force to move the block. Okay. So now here we are how to get the shortcut, how to get the answers in shortcut way, in small way. It is a very long way. Okay, smaller way. How to get that answer? Okay. Try to see the scenario here in this question. How we will get answer in shortcut way. So see the scenario here. Okay. So here we have what guys? See the point here. What we have? See the point here. We have what? A wedge, tapered block and 2 wedges. So what we have? A tapered block and 2 wedges. This is a, this is a B, C. Okay. Try to see the scenario. A total load is how much? 3000 G. Total load is how much? 3000 G. On this side we have a P. On this side we have a P. Okay. See the scenario here. Now angle of friction for this one, phi1. Angle of friction for this one, phi2. What is the value of phi1 guys? What is the value of phi1? And what is the value of phi2? 21.8 degree. Okay, good. Now, what will be the load on each wedge? Load on each wedge will be how much, guys? Load on each wedge. Okay, load on each wedge will be how much? 1500 G, 3000 G divided by 2. So, load on each wedge will be equal to what? 1500 G. That will be load. Okay. Now, in yesterday's numerical, means in we have seen few cases. Okay. In last lecture, what we have seen? Okay. We have seen what? Different cases of horizontal force. Suppose if you want to move the force, see, this is a block. Okay. Just I am going to give you a revision. This is a block whose weight is how much guys? mg. And we are applying a horizontal force. So what will be this value? This is what mg. What will be the value of F here in this scenario guys? Tell me. For this scenario, what will be the value of F? See, we have seen the relations. mg into tan phi. Okay, for this scenario, F will be equal to what? mg into tan phi. Then guys, we have seen another scenario. Alpha. Okay, see the point here. Okay, on inclined plane, this is what our block. Okay, here we have a weight, a load here is what? mg. This angle is, okay, so what will be the F here? See the point here. See, go through your notes. Just check it. What will be the F here? mg into tan of 5 alpha plus phi or 5 plus alpha? Okay. So these things we have studied in our last lecture. Okay. See the point here. Different cases of horizontal force. So now what is the use of that cases here? So how to calculate the value of P directly? Okay. See the point. How to calculate the value of P directly. Now if you want to move anything horizontally, how much force we require? Mg into tan phi. How much force we require, guys? Mg into tan phi. So this is what wedge C. And if you want to move the wedge C horizontal plane, on this horizontal plane, how much force will require? If you want to move this wedge C, how much force will require? 5. And here coefficient of friction is how much? 21.8. So this will be equal to how much weight will be here? On C is acting 1500 G into tan phi 2. Okay, see the scenario here. Everyone, see the scenario here. So P is how much? If you want to move this plane. Now just observe this, that. Can we consider, means this scenario moving C on this one, on this A, means it is moving up here, means C. Means if you reverse this one, try to reverse this drawing, guys. Just reverse your laptop. What you have to do? Just reverse your laptop. Just for the sake, what you have to do? Just reverse your laptop. What you will come to know that? This will be what? You will get like a scenario like this one. Means what will happen? A will come down and C will go what, guys? C will go like this. Means C is going up on this plane. What will happen, guys? C is going up on this plane A. Means if you reverse the scenario, what you will be? Just look like this. Just look like this, guys. Or for you guys, for me it is not possible because I have to remove the board and then turn the things. But for you, just turn your laptop by 180 degree. Just guys, turn your laptop by 180 degree. Just do it. And those who are watching on mobile, for them is very easy. So what will happen? Guys, what you will feel? Just turn your laptop. Okay. Okay. A will. Okay. Means A will go down. Yes. What you want to say? Means mass C will go up on this slope of A. And if you want to go, mass C will go up on the slope of A. Means if you turn this drawing, okay, so C will what will go? C will go is what? C will go up on this plane of A. So I turn this one by, okay guys, are you getting a point? Try to see the scenario here. So if anything is going up, how much force we have to apply horizontally? How much will be that one, guys? 1500 G into tan of how much here? Alpha plus what, guys? This will be what? Phi 1. Okay. So here mass C is moving on the horizontal plane and mass C is going up on the inclined plane. Means that is what a scenario here. Try to see the point here. So P will be equal to what? 1500. Okay. Guys, any doubt in this expression? Everyone, observe this expression. This is a shortcut way to find out the solution of this question. Okay, anyone have any doubt in this expression? Anyone have any doubt in this expression? Try to see this point. Okay, good. So here, 1500. Okay, see the scenario here. 1500 multiplied by 9.81 into tan of phi 2. What is the value of phi 2, guys? Here 21.8 plus 1500 multiplied by 9.81. Everyone, see the scenario. Tan of alpha. Alpha is how much here? Angle of plane 5 degree plus phi 1. Phi 1 is how much? 16.7. Okay, see the scenario here. Please everyone do this calculation with me. Please do this calculation with me. Same answer. 1 same answer we are getting, guys, huh? 11741.4 Newton. See, we can tally this answer, but for this much answer you will not get a see how much answer we solved. See, this is the extra part I have given to you. But see, only in 5 minutes we can solve. Here I explained 10 to 15 minutes. I have taken 10 to 15 minutes, but we can solve this in 5 to 10 minutes. But for only this much you will not get a complete marks. So don't worry. This is the method only for checking your answers. Okay, you got this point, guys? Anyone have any doubt in this discussion? Okay, guys, you can write down this for your reference, but no need to write down this for your reference. Do you need this one? Just after writing, okay, just after writing all these things now. Okay, just write down after writing, then below this one, just then this after that. Okay, first of all draw this drawing. After the drawing, what you have to do? Write down these things, and then this one, then. Okay, please everyone, and then at the end please write down this explanation. Okay, why we consider all this formula.